purpose of inference, statistical inference, is to disprove or fail to disprove some currently held belief about a population. So you start with a population of interest. And there are various what's called parameters. These are currently believed percentages or means, averages that are held about this population. The example that I used in class was that, talking about drug A for a population of interest of some group with a particular illness. And drug A has a cure rate, cures 0.3 or 30% of this population. So this cure rate for drug A would be called a parameter and is referred to by the letter lowercase italic p. So the cure rate for drug A for this population of some group with the illness is 0.3. Now, you have developed or some company that you work for has developed a new drug. And they think the drug has a higher cure rate. So they hire you to investigate this. So what do? You gather evidence, which is a sample. Let's put evidence. Okay, inference uses evidence to prove or disprove or fail to disprove a currently held population parameter. So you take a sample from the population of interest that is random, independent, not too big and not too small. But the most important of these is that it's random, and therefore it represents the population. Okay, so your sample represents the population. Therefore, you expect that the sample statistic will be close to the truth. That is the true proportion of people that are cured by the new drug. Okay? So, you take a sample of people, a random sample, you treat them with the new drug, and you get a cure rate from your sample, a sample statistic, and that's let's call it 0.35 for the sake of argument. Okay? Now, p hat, little italic p with this little arrow over on top, it's called p hat, and this symbolizes the sample statistic. Okay, parameters are estimations. Statistics are always specifically known. Why? Because you collected the data and you measured the statistic, so it's always very specific. Parameters are always somewhat of an unknown mystery, whereas sample statistics are exactly known. Okay, so now you have your parameter and you have your sample. Now you're going to make a hypothesis called H sub 0. This is the null hypothesis. Symbolized. The words null hypothesis are symbolized by H sub 0. Let's write these over here. So you would write H sub 0 colon, if you're following the protocol, P equals 0.3. The population parameter for the cure rate for this population is 0.3. Now you're going to have an alternative hypothesis, which is based on your new drug, which is that the cure rate is greater than 0.3. Now, you only have three possibilities. You can either say, for the alternative hypothesis, either it's greater than, not equal to, or less than the null hypothesis, the currently held population parameter. Okay. Now, your sample meets all the qualifications of being taken. So now the question is, assuming the truth of, let's use the symbols here, just kind of say words, of H sub 0, that is the null hypothesis, what is the probability of p hat? Okay, so assuming, now remember, p hat was taken randomly. P hat is a result of a random sample. So assuming that H sub 0 is true, what is the probability of p hat? So what does that mean? Well, let's draw a normal curve. It doesn't look very normal, but anyway. Let's put P. Now, the null hypothesis parameter is symbolized by P sub 0, and that's taken from H sub 0. So here's P sub 0, which is 0.3. Now, I'm doing this as an explanation. You don't have to reproduce this now. There'll be something you want to do later on in the course. Now, here's P hat at 0.35. Now, obviously, p hat is 0.05, bigger than 0.3. The question is the difference significant? That question depends on this question, on the probability. The more improbable that p hat looks, assuming that P sub 0 is true, the more likely it is that p hat is significant. Why? Because the more improbable that p hat is, the more standard errors there are between P sub 0 and p hat. Standard error simply being a measure of distance, a yardstick, that's created by the statistics of the sample. It's all internal to the sample. Okay? All right. So if p hat appears to be two or more standard deviations, either to the right or to the left of P sub 0, then the probability of p hat occurring, assuming that P sub 0 is true, is unlikely. It's below 5%. If p hat is unlikely to occur randomly, assuming H sub 0, then reject H sub 0. Why? Because we expect that if p hat is far enough away from P sub 0, then p hat is closer to the truth than P sub 0. So here's another way to draw the picture. Let's draw it like this. Let's draw another normal curve. This time, let's put the truth in the middle. Okay? Now, here's p hat. And if p hat and P sub 0 are really far apart, then we're going to see P sub 0 over here somewhere. And we expect that p hat is closer to p, because p hat is drawn to P by the process of random selection. Because the sample is random, it represents the population, which means we expect that the sample statistic p hat will be close to P. And if p hat is far away from P sub 0, then we're going to take a different view of circumstances, and we're going to say p hat is closer to P than P sub 0. P hat is closer to the truth than the null hypothesis. We will therefore reject the null hypothesis. Where do we have it here? We will reject the null hypothesis, and we will say, so we'll reject it. And there is evidence, this is all we're going to say. We're not going to make any statement that P, the true proportion of people that are cured by the drug, is greater than 0.3 P. The true proportion of patients cured by B is greater than 0.3. That's all we're going to say. But that's the conclusion of the inference. And so now we have to come up with a new population parameter which will be based on p hat. But we're going to call that a confidence interval now. We won't go into that right now. Okay, so let me review. Inference. Inference really begins with your interest in overturning. You want to reject the currently held opinion, the currently held belief about the truth. Okay, in this sense, science is always revolutionary. All research is revolutionary. It's attempting to overturn or reject some previously held belief about reality. Okay, in this case, we're talking about a drug. And the previous drug cured 30% of this population of interest, a group that has this illness. It's not the whole population in the world or in the country. It's the population of patients with this illness. Okay. And the currently held belief, based on probably thousands of cases of patients who have taken this drug, is that the cure rate is 0.3. So that's a parameter about this population, p equals 0.3. So how are we going to overturn this belief? We're going to get a sample. We're going to get a random, independent, not too big, not too small sample that represents the population. Because the sample is random, you expect that the sample statistic taken from the sample, which is simply going to be a count of how many people were cured. Let's say you take 100 people and 35 got cured. Okay? So we expect that the sample statistic will be close to the truth. It won't be, we don't expect it to be the truth, but we expect it to be in the vicinity of the truth. By that we mean a couple of standard deviations or less. In this case, to the right, because we're expecting it to be bigger. Okay, so we have, and we got a p hat of 0.35. Again, I'm just making all this stuff up. Okay, so we start out with the null hypothesis. That's the statement of the currently held belief about the population parameter. And that is 0.3. Now, alternative hypothesis is based on what are we trying to prove. This is your interest. This is what you are seeking to establish. Okay? So that's based on what are you trying to prove? Well, you're trying to prove that your new drug is better. So you're going to say, all you're going to say for the alternative hypothesis is that the population parameter, the proportion of people that are cured by the new drug is greater than 0.3. Okay. Assuming the truth of H sub 0, what is the probability of p hat occurring randomly? Okay, and is the difference between p hat and p sub 0, the null hypothesis, significant? Well, If there's if p hat's 2 or more standard deviations away from p sub 0 to the right, that makes p hat look unlikely to occur randomly, assuming that p sub 0 is true. But p hat did occur randomly. P hat did occur randomly. Why? You randomly selected it. So what does that mean? That means this assumption, if this probability is low enough, if it's 0.05 or lower, then we can no longer assume the truth of H sub 0. If p hat is unlikely to occur randomly, assuming H sub 0, then reject H sub 0. And we're going to draw a different picture where p is truth, and p hat is somewhere in the vicinity of truth, 2 standard deviations or less, and p sub 0, actually p sub 0 would be over here somewhere. Okay? And so p hat is closer to the truth than it is to p sub 0. So that's how we're going to see it. And therefore, here's p sub 0 at 0.3, and here's p hat at 0.35. So we're going to start thinking that p, the truth, is bigger than 0.3. Now, we don't think it's 0.35, but we think that it's bigger than 0.3. Okay? That's inference. Any questions? Get back to me and I'll follow it up.